In this video, we're going to take a look at SAT math problems for the SAT math exam preparation for the year 2021. 7 problems, full solutions worked out for you here today on High Peak Education. What's going on, everybody? Hope you're having just a wonderful day. We hope this channel is just a value add to you. Please share the channel and subscribe, because we make videos on SAT prep, math, physics, statistics, computer science, meteorology, all kinds of things that are hopefully useful to you. And we want to hear from you in the comments about how you're going to use this content and what would be most useful for you in the future. So please try to pause the video and make sure that you give a shot to each of these problems before you get started. So let's get into today's content.
A painter will paint n walls with the same size and shape in a building using a specific brand of paint. The painter's fee can be calculated by the expression NKLH, where n is the number of walls, K is a constant in units of dollars per square foot, L is the length of each wall in feet, and H is the height of each wall in feet. If the customer asks the painter to use a more expensive brand of paint, which of the factors in the expression would change?
K.
You think K?
Yeah.
Yeah, I agree. Good job.
Isn't it just because that's how much units per dollar per square foot?
Yeah, because are we going to necessarily paint any more walls?
No, we're just going to use...
Right. So N would be more walls. Are the walls going to be taller? No. So it's not H. And then are they wider? I'd say no, so it's not L. So it's definitely K. If 3R equals 18, what is the value of 6R plus 3? Okay, so you say 39. I agree. So you're saying that R is 6, and then 6 times 6 plus 3. Which of the following is equal to A raised to the 2/3 power for all values of A?
B or... I think it's B or D.
So it is B or D. Good, so let's eliminate A and C. Those are incorrect. So it is going to be D, and let's walk ourselves through how we know this. So this should be a little review from algebra, but this is, for a lot of people, some tough stuff. What does the 2/3 power mean? What do we call the 2? What do we call the 3?
Numerator and denominator.
Yes, so numerator and denominator of the exponent. Okay, so this right here is the numerator of the exponent, and then down here, this would be the denominator of the exponent. What do we actually call the parts of the fraction in the exponent, I guess is what I'm saying. Yeah, so one of them is the power. Do you know which one that is?
2.
Yes, the 2 is the power. And what do we call the 3 there? So we would call that the root, okay? Here's the way I always remember it. I always say powers are more powerful than they're on top, and roots grow in the ground. So that's why they're on the bottom. Again, it's kind of a little dumb thing, but sometimes if it's dumb, it really kind of sticks in your mind, okay?
Yeah.
I don't know if it helps you, but powers are more powerful, they're on top, roots grow in the ground, so they're on the bottom. Do you see that this is the second power, in the second power, and it's the 3rd root, exactly. So if you're going to do a second power and a 3rd root, that'd be this one. Now have a look at that. It's because it's a squared, that's the second power, and then the 3rd root is cube root, correct? Okay, so that's a little tricky. It says the number of states that joined the United States between 1776 and 1849 is twice the number of states that joined between 1850 and 1900. If 30 states joined the United States between 1776 and 1849, and X states joined between 1850 and 1900, which of the following equations is true?
I just used B to get the answer. I don't know if it's necessarily the right answer to this question.
Okay, so let's walk through this. 1776 to 1849, the number of states that do not join the United States is twice the number of states that joined between 1850 and 1900. Let's call this period A, and let's call this period B. So 2 times B equals A. Would you agree with that?
Yeah. And
2
so,
times period B. So let's see. If 30 states joined in 1776 to 1849, so that's A, right? So that's 30. But then if X states joined from 1850 to 1900, then that's X. Yeah. If 5 over X equals 15 over X plus 20, what's the value of X over 5? So can you tell me what you might do to solve this? So I can... Good. So you're going to have 15X equals, what is that? 5X plus 100. Subtract 5X from both sides, right?
yeah.
So then 10X is 100, and that's X is 10, right?
Yeah.
But then they want the value of X over 5. So what would X over 5 be? Not quite. It's 10 over 5.
2.
So it's 2. Yes. Okay, so this choice. So whenever you have these kind of funky multiple choice tests, just be careful you give them the sort of right answer that they're looking for. Don't just, because notice that this is a ghost answer. 10. Because, I mean, we came up with 10 for X, but a lot of people are like, oh, I'm just going to give them X. Be careful. Answer the question. Okay? So that's part of what happens with these tests that are sort of multiple choice. You know, they're trying to trick you sometimes. It says, if X comma Y is a solution to the system of the equations above, what's the value of X minus 1? Okay. So let me ask you this. Have you looked at before in algebra a system of equations?
Yes.
Okay. So what do we mean by when we say a system of equations? Okay. So it's multiple equations with multiple what?
What are those called? X and Y.
Yeah, so it's multiple equations with multiple unknown variables to solve for. That's one way to define it, correct?
Yeah.
So let me ask you this. If you have two variables, X and Y, like you were saying, how many equations do you require to solve that? Yes, 2. There always must be as many equations as unknowns. That's an important property in math. Now that actually has really deep meaning behind it in terms of why that is. I'm not going to go into all the deep meaning. But the point is, you need as many equations as unknowns. So if we have 2 equations and 2 unknowns, that can be solved for both X and Y. Now there's a couple ways to solve a system of equations. Can you think of one of them?
15 minus 2x is equal to negative 3y.
We can do that. Yep. So you're starting off on one method. What method? Do you know what method you're starting off on? So generally there's 3 methods you can use to solve these things. So the first one that you were actually getting at was the substitution method. So we can do the substitution method. So what that means is we would go, just like you said, negative 3y equals negative 14 minus 2x from here. And then we would go divide by negative 3. So we would have y equals, what is that? 14 over 3 plus 2/3 x. And then what we could do is we could substitute that in here for y. Now that works, but only in certain situations is the substitution method useful. I mean, I don't know about you, we've got some pretty horrible fractions going on, right? This is okay, but in this case, it's going to be hard to finish it out. Okay, and I'm going to suggest, for the sake of time, we not finish it out, because you have to take 2 times, 14 over 3 plus 2/3 x, combined x's, find x, go back, get y. A lot of fractions, right? The second method is the elimination method. Now, the elimination method says try to eliminate x or y. Now, the idea is that we want to get the coefficient on either x or y to just be the opposite of the other one, but the same absolute value, the same number. So what do I mean by that? Well, what if I multiply this equation by 2? I think I would have 6x minus 4y equals negative 12. Do you agree with that? Just using the distributive property. If I wanted this to be negative 6x, so I want the target negative 6x. You see what I'm getting at? I need to multiply 2x by what number? negative 3. There we go. Negative 3. So that's going to be negative 6x plus 9y equals, and then we need negative 3 times negative 14, which is going to be the same thing as 14 times 3. So that should be 42, right? And then now, do you see what's going to sort of somewhat magically happen? We're going to add these together, and what happens to the x's?
They cancel.
They just cancel out, right? And they're going to have negative 4y plus 9y gives 5y. And then what happens when you do negative 12 plus 42? 30. Okay? Now, I don't know about you. I think that's a lot easier because it avoids horrible looking fractions, right?
Yeah.
So what should y be? Not 7. 30 divided by 5 is what? 6. Yes, 6. Now the cool thing is, once you have y, you can go back to any equation you like and solve for x. I don't know about you, I think the smallest numbers are the 3x minus 2y equals negative 6. Would you agree? 3x minus 2y equals negative 6. But now we know that y is 6. So that's 3x minus 2 times 6 equals negative 6. So that's 3x minus what? Oh, yeah, minus 12. Equals negative 6. And then how do we finish solving that? Yeah, plus 12.
It'll actually be 2.
Let's see. I think you're pretty fast. Yeah, you're faster than me. X is 2. All right, good. So now, again, answer the question. Our answer should not be either of the values of x or y. It should be x minus y. So we need 2 minus 6, which is negative 4. So that should be our answer. And I'm hoping that's in there. It is. Okay? I think it's useful to go over the graphing method. So 2x minus 3y equals negative 14, and 3x minus 2y equals negative 6. Those are both what kind of graphs if you put them on a graph? They're what kind of shapes? Okay, it starts with an L.
Linear?
Yeah, wouldn't these be linear functions?
Yeah.
So these are linear functions. Okay? And remember, they're in what form? Okay, have you ever seen this form before? This is called the what form of the equation of a line. So the standard form of the equation of a line. Have you heard of that before? Okay, so anyway, the point is A is a constant. Let me just put it this way. A, B, and C are all integer constants. And they're no fractions. But in other words, part of the reason I did the subscript 1 on all of these is because there's 2 lines with 2 different constants.
Yeah.
So I'm just going to put the subscript 2 on the other one here. See that?
Yeah.
So since we have 2 lines, there's just 2 different sets of constants, so to say. By the way, you can actually get this into another form. Y equals mx plus b, right?
Yeah.
But it would be m1, b1. Then there'd be another line, y equals m2x plus b2, correct?
Yeah.
So you could change the form. Let's not go through that right now for the sake of time. But the point is, these are lines. Now, solving a system of equations of lines is not usually that difficult because you can typically use the substitution or the elimination method. But sometimes some graphs are so difficult that a graph is going to really help you. What I'm going to do is I'm just going to type those 2 equations into Desmos. So 2x minus 3y equals negative 14. Okay, and I'm going to do that as the purple one. Then we've got 3x minus 2y equals negative 6. And let me go ahead and do that one in orange. So that's 3x minus 2y equals negative 6. Okay, so you can see those are the 2 lines I put in on Desmos, right?
Yeah.
But yeah, hopefully you're getting the idea of what this looks like now. So anyway, all I was getting at before is, here's another way to find the exact same solution. So the solution we found was x was 2 and y was 6, correct?
Yeah.
And you can see that if you intersect those 2 lines, the one that's in purple and the one that's in orange, this is exactly what we have for the solution point, right? X comma y is equal to 2 comma 6. Okay, so that's the intersection point. And think about that. That's why it's the solution, because it's like saying, give me both of those lines and find the point x comma y for which they both have the same value. So that's why it's solving it. Does that make sense? So that's another method. Now again, in some cases you'll have like, you know, a parabola and then a line. So you can imagine like that's a lot harder to solve via, let's say, substitution or elimination. So sometimes the graph is really helpful, you know, to get the points of intersection, right? By the way, lines can only ever have at maximum one point of intersection unless they're the same line. Think about this. Let's go over the 3 possibilities for lines. Lines intersect. How many solutions are there? 1. Just 2 straight lines. But if the 2 lines are parallel to each other, how many solutions? I wouldn't say 2. If they're parallel, are they ever going to intersect? No. So I would say, how many solutions? 0. So it'd be no solution, right?
Right.
That is possible in math. And lastly, what if the 2 lines are right on top of each other, sort of overlapping? So those would actually have infinitely many solutions. Okay? Because every point x comma y works. It depends upon the shapes you're looking at. Lines can only ever have 1, 0, or infinitely many solutions. Now look at this. Do you see the parabola that I've got with the straight line? Do you see how?
1?
Well, this would have 2 solutions, right?
So, do only linears have 1 infinite or 0?
Exactly.
Okay.
So they're going to have 1, 0, or infinite number of solutions. But notice, if you have a line and a parabola, you can have 2 solutions, or you could have, say, 1 solution. Let me get this just right. You see that right there? Like that. Or you could have no solution, right?
Right.
I mean, that's clearly just like a line up there, right?
Yeah.
Okay, no solution. So, you get the idea. The function f is defined by a polynomial. Some of the values of x and f of x are shown in the table above. Which of the following must be a factor of f of x? What do we mean by a polynomial, by the way? Okay, so let's talk about polynomials. Let me ask you this. Is sine x a polynomial? No, it's a trig function. Okay. Is x over x minus 1, is that a polynomial? No, because this would be what you would call a rational expression. Would x squared plus 2x plus 5 be a polynomial? Yes. Okay, so polynomials are what you often think of in algebra, right? It's basically stuff to powers, right? By the way, as a quick note, remember we did a few minutes ago, x to the 2/3? Let's say I had x to the 2/3 plus 5. Is that a polynomial? Okay, so you would say no, and it's because this right here must be an integer. In fact, a non-negative integer. You can't have x to the minus 1. You can't have x to the 2/3. You can have x to the 0. X to the 0 is just 1, right? Just a number. But it has to be a non-negative integer. So this right here is a polynomial. Now, by the way, let me ask you this question. When we typically have polynomials, let me try to think of an easy one here. Okay, suppose you have x squared minus 5x minus 4. Yes. What do we typically do if we try to solve this? If you're trying to solve for x? Yeah, you're right with the parentheses, but the term is not distribute. So don't worry, buddy. I mean, one of the things I'm helping you a lot with today, it's fine. It's vocabulary, but it's good to know the words. If you're speaking to a group in a professional society, you know, you want to use the big words, right?
Yeah.
Because then you're using very specific language, right? Somebody knows exactly what you mean. We don't want to distribute, we want a reverse of what we call FOIL. We want to reverse distributing parentheses. So we call that factoring, right? So factoring would be this, just as you alluded to, right?
Yes.
Okay, So that's just a reminder of however many months or years ago that you solved this, right? So what you do is you typically have this, and by the way, when it's equal to 0, do you know what this kind of form is called? Standard form. Have you heard this before? When you have something equal to 0 on one side, typically the right-hand side, I mean, it's typically like, that's usually how we do it. We do the math on the left, the number on the right-hand side is 0. So if you have 0 on the right-hand side, that's what's called standard form. And by the way, the reason we have standard form is, do you see that x is in more than one term?
Yeah.
Can you solve for x directly? In other words, you just get x? No, you can't, right? Technically you can't, because it's in more than one term. And in one term it's squared, and the other term it's linear. So if you think about it, we have to use what's called the zero property of equality. What in the world does that mean? Well, the zero property of equality says, look, if you have two things multiplied by each other and they're equal to 0, call those things thing A and thing B, right? I could have called them thing 1 and thing 2 if I was thinking about the Cat in the Hat, right? So thing 1 and thing 2. Okay, so thing 1 and thing 2. Well, if I have thing 1 times thing 2 and it's equal to 0, then either thing 1 equals what? Not x, but thing 1 equals what number?
0.
0, or thing 2 equals
0.
0. Because you have two things multiplied by each other, they equal to 0. Either the first thing is 0 or the second thing is 0. That's the zero property of equality, and that's why standard form is so useful. Now, that being said, let's think about how we might factor x squared minus 5x minus 4. Now, do you know what that would factor to? And sorry, one more thing. I meant to do plus 4 here. I'm sorry. So x squared minus 5x plus 4. So yes, you'd have start with x and x. Nice. In other words, we need two factors of positive 4 that add up to negative 5, correct? Exactly right. Okay, so there we go. So we have to have negative 1 and negative 4. Now, with that in mind, do you see that either x is going to equal 1 or x is going to equal 4? Now think about this. When x is 1 or x is 4, what's the value of f of x? I think it's 0, right? Because the entire polynomial is 0. Do you see what I'm saying? This table is a polynomial. By the way, it could be a quadratic, it could be a little larger polynomial, who knows? Sorry, which of these is a factor that corresponds to, if you put in that x value, then f is 0? Which of these x values gives you the function being 0? Yes, 4. Do you see that?
Yeah.
So that's going to be which choice?
X minus 4c.
Yes, so C, because that exactly goes along with this. Do you see that?
Yeah.
Now, by the way, let's put it this way. The more you do this, the more you'll be able to answer more quickly. First of all, I had to remind you what a polynomial was, just a little bit. Secondly, I had to remind you what factoring was. But then each of these things that comes out of factoring, this right here is called a factor, right? The two things you factorize to, each is called a factor. It's just the term we use for it. And once you realize that x minus 4 is a factor, then do you see that, like, if you have x minus 4, but if you let x equal 4 in there, then this parentheses becomes 0, right? That factor becomes 0. Does that make sense?
Yes.
So then that's why this tips you off that, when x is 4, you get 0 for function, so x minus 4 is the factor, and that's the correct answer. In the figure above, lines K, L, and M intersect at the point x plus y equals u plus w. Okay, which of the following must be true? X equal to z, y equal to w, z equal to t. So is it the first two, the first and the last, the second and the third, or all of them. Okay, so let's walk through that. Here's the important fact that we know. Okay, x plus y equals u plus w. So that means this angle is equal to this angle, right? You agree with that?
Yeah.
Okay, so those angles are the same. Now, let me ask you this question. Okay, let's see. I think x is going to equal t, right? Because those are vertical angles?
Yeah.
Okay, and then let's see, y equals u, and then z equals w. Okay. So then we need to say, okay, but x plus y, so think about this, from these two, x plus y, if we add these equations together, should equal t plus u. But t is equal to, but we also know x plus y equals u plus w, right? So if we subtract these, then we would get 0 is equal to t minus w. You see that?
Yeah.
That's kind of that systems of equations thing we were doing before. So then t equals w. But t is x. Do you see that? Up here, t is x. So that's x. And then w is z. So x is z. So that one's true. Right? Do you see how I reasoned that through? Mm-hmm. And then, by the way, we know that there has to be at least 2 of these correct, right? So let's just check these other ones. Does y equal w? Well, notice that here we have w equals t, which is a true statement, right? But the question is, does y equal t? Well, y equals u. Okay, so that means w equals x as well, right? So there we go. So z, x, w, and t are all the same, right? But then y is equal to u. Whoops, hang on, I wanted to extend this. So z and x and w and t are all the same, because w equals t, but then z and x, okay. But then y is u. So is y equal to w? I don't think so. Whoops. So I don't think so. But then is z equal to t? Well, yes, by the transitive property. What has to be? Yeah, because if you look at it, we have to have at least 2 correct solutions, 2 of those, right?
Y is equal to w, then obviously z equals equal to t.
Right. Okay. But if you think about it, like y is equal to u, but u is not the same thing as x and z and w and t. So there we go. So it has to be 1 and 3 only. See that?
Yeah.
So that's where it says not drawn to scale.
But if it were drawn to scale, all those angles would equal the same.
So if it were drawn to scale, then they all would be the same. Exactly. But that's why they say not drawn to scale. It says, in the xy plane, the parabola with equation y equals x minus 11 squared intersects the line with equation y equals 25 at 2 points, A and B. What is the length of AB? So how will we try to solve this?
Minus squared is equal to 25.
Beautiful. So x minus 11 squared equals 25. So how would you start to solve that for x? So remember, in algebra, the goal is to isolate for x. I'm going to get x by itself. So how do we get rid of the squared? So you can't add 11 because by order of operations, the squared has higher importance. So you can, and if you did that, you'd have to square out the x minus 11 squared. That's fine. You can do that. But I'm going to suggest there's probably a faster and more direct way. How can you get rid of the squared immediately and then get this 25 knocked out? Not divide. What undoes a square? What's the inverse of a square? What's undoes a square? Yeah, square root, right? Now, by the way, whenever you insert a square into the problem that wasn't there in the first place, you need to insert plus and minus, right?
Right.
If I ask you, what's the square root of 25, what would you say? 5, right? But if I ask your friend Bill, hey Bill, what's the square root of 25? Bill could say -5. And would he be incorrect? No. -5 times -5 is still 25. Okay? So you need the plus or minus because there's uncertainty. Now the square root of x minus 11 squared, that's just x minus 11. Do you see that?
Yeah.
And then this is going to be plus or minus 5. You okay with that?
So you would add 11.
Then you can add 11. So that's x equals 11 plus or minus 5, which is the same thing as saying, let's see, if you subtract 5, you get 6. And
X
if you,
equals
right. Now, if you think about this, consider what the graph would look like. Okay, so let me try this again. Okay, so let's let this be positive 11. There we go. Sorry for that. And then, okay, so then parabola up, like so. And then here's y equals 25, right?
Right.
Again, this is just a sketch. So you see that this right here is, whoops, this right here is 6. This right here is 16, right? So you see that?
Yeah.
But then the question is, this is point A, this is point B. We want to know the length of AB. So what's the distance between 6 and 16? 10. So that's the answer, right? Now notice, we actually could have almost figured that out from this moment. Once we got to this moment, x minus 11 equals plus or minus 5. Do you see that 11 here is going to be the so-called axis of symmetry of the parabola? Do you see that?
Yeah.
So that means if you go left 5 or right 5, it's symmetric, right?
It's still 10.
Yeah, it's still 10. So like, that's another way to reason it. So if you need to save time, if this is an exam, that's one way to save time, especially if it's a multiple choice, okay?
All right.
So hopefully you saw we did lots of different kinds of problems today. We did algebra, some geometry. We did a word problem to begin. We talked about various concepts in terms of powers and roots. We discussed how to find the length or distance of a line. We sketched graphs. We did all kinds of things. So hopefully you're getting an idea of how to solve SAT math problems. And hopefully these 7 problems have given you an idea of the level of difficulty and the types of problems that you might see on the exam. So hopefully this is the kind of thing that is really beneficial. And again, we really want to hear from you about how these videos are benefiting you. And thank you for watching High Peak Education. Please smash that like button. Please comment. Let us know what you would like to hear from this channel, from these videos. And we thank you for watching. Look forward to seeing you in the next video.